This lesson we're going to continue with polar and rectangular conversions, but today's center is all about converting equations. So first, let's rewrite the properties that we learned in the previous lesson. So because it's right triangle based, we know that r squared is equal to x squared plus y squared, and that r is equal to the square root of x squared plus y squared. So there'll be some things there where we can substitute using those two properties. We can also talk about the polar components. We know that x equals r cosine theta, and that's when we're converting polar to rectangular coordinates or points. If we solve for each of the letters, we would get x over cosine theta, and if we solve for cosine theta, we get our trig ratio that we're used to, which is x over r. And same thing with the y equals r sine theta, and then r is equal to y over sine theta, and sine theta is equal to y over r, and that's what we're used to as we did right triangle trig. So here's the deal. If we're going to convert the polar to rectangular, I am looking for x, y, or both. Okay, so x, y, or both. So when we start this one, the very first thing we're going to do is we've got the 2 theta in there, and that's the double angle property. So from our trig sheet, r is equal to 3 times 2 sine theta cosine theta, and then that gives me r equals 6 sine theta cosine theta, and I needed to do that because I need single thetas to continue my conversions. So I'm going to leave the r for now. I'm going to take my sine and rewrite sine as x over r, multiply symbol there. Sorry, the cosine is x over r, and the sine is y over r. You know what? Let me write that so that you can see that in the correct order. Oh, excuse me. All right, so now we have r equals 6xy over r squared. And then what we're going to do is we're going to multiply the r's. So r cubed is equal to 6xy. So this right side looks good because there's x and y. Now we're going to substitute in for r. If we look at the menu above, r is the x squared, square root of x squared plus y squared. And then the best, we're going to raise that to the third power. And the best we can do is know that a radical times itself would leave the x squared plus the y squared on the outside, and still an x squared plus y squared underneath, and then equals 6xy. And so that is definitely the good enough. Sometimes there's different variations. Some people set it equal to 0. That's fine as well. All right, let's look at the next example. So I'm starting with r equals 2 cosine theta. I'm going to leave the r for now. I'm going to write down the 2. I'm going to convert to x over r. If I show the product on the right, I get 2x over r. And then we're going to multiply both sides by r. So r squared equals 2x. Now reevaluating, I need an x. The r squared has to go. Looking at the menu on the top, x squared plus y squared is what I'll substitute in for r squared equals 2x. And at that point, we have enough to say, you know what, we've got x's, y's, or both in that case, and our conversion is complete. Okay, now we'll go ahead and look at this one. Now we're going to go the other way. So the first thing we notice is x squared plus y squared. So that's going to be written as r squared. And then I'm going to copy the 4. And if I look at my menu on the top, x is equal to r cosine theta. And so now, remember, the x's and y's have to go. They have to be replaced with r's and thetas. So I'm going to leave the r squared. I'm going to go ahead and multiply by my 4. And now what I'm going to do, now don't divide by that r, we're going to lose a root. So let's go ahead and subtract. Okay, now what we've got, the question I've asked you several times throughout this year is there's 2 terms on the right side. We're going to factor the GCF. And we're going to end up with r equals 0. And we know we can't have a directed distance of 0. R minus 4 cosine theta equals 0. So r is equal to 4 cosine theta. And that, if we look at what we've got there, that could be an equation of a circle, and then that's the polar equation that would correspond. All right, last example here. We are going to look at this one. Now this one, you might remember the general equation of the circle. So we can't do anything with the squared. So the first thing we have to do is we have to multiply out. I'm not going to show the FOIL. If you get stuck, you should treat this one like x minus 3 times x minus 3. And the other one is y minus 2 times y minus 2. So when we FOIL, we don't want to miss terms. So x squared minus 6x plus 9 plus y squared minus 4y plus 4, and that equals 13. And what we also know is that the 9 and the 4 is a 13, and that'll cancel it out. So now if we rewrite, and we're going to do something clever here, we're going to put the x squared and the y squared together, because we know that's r squared minus 6x minus 4y, and then the numbers all cancel, and that leaves me with a 0. So now I know this guy right here is r squared. I am going to put in r cosine theta in place of the x, and I'm going to put in r sine theta in place of the y, and then I'm going to show my multiply step. Now what you should see, we do have 3 terms on the left side, but I do have a GCF. So in having that GCF, I'm going to go ahead and pull that. So r minus 6 cosine theta minus 4 r sine theta equals 0. Again, directed distance cannot be 0. So r minus 6 cosine theta minus 4r sine theta equals 0. So then r equals 6 cosine theta minus 4 sine theta. And that little guy right there, that should have been 4 sine, yeah, without the r, so minus 4 sine theta. And that is our conversion. Okay, so the past 2 lessons have been about converting. One was polar points, and then today was polar equations.